class. This is the last video lesson for Unit 2. In this video, we'll cover word problems in general. When solving an application problem, these 4 steps tend to help you keep yourself organized. Make sure you read the whole problem, understand what they're asking you for, understand what they're telling you. You might have a problem that involves apples once and it's a proportion, and it involves apples another time and it's a percent problem, apples and it's a multiplication problem. So you can't just look at what's being talked about here. You have to understand what they're asking you for and what you know. Devise a plan, maybe look at a picture, draw a diagram, then carry out the plan, and then look back. Does your answer even make sense in the context of the problem? Just like with percents, if you're off by a big amount, you should have some sense of what you think the answer is, and then you should look at your actual computed answer and see if it makes sense. Do you make sure you know the key terms? Is it like something you've done before? Maybe you did a problem about, we did a problem about McDonald's hamburgers in the last class, but maybe this has to do with the price of a cell phone. So they really are the same thing. What is it that's similar? What processes do you have? What are the units going on? Drawing a picture, using a variable. You saw in the last, sometimes I wrote a variable, but sometimes I just put a box so I knew what I was going for. Looking for a formula. In this section, there will be some problems that involve formulas, but the formulas will be given to you. So it's not something you need to memorize. It'll be in the problem and you'll need to know how to use it. Most of the strategies I'm going to demonstrate are going to be solving equations like we did in homeworks 13, 14, and 15, but you might have a trial and error type strategy. And then did you answer the question? Remember last time we would do a percent problem and we'd figure out the tip but not the total bill. So make sure you've answered the question at hand. Bruce Springsteen and Celine Dion generated the top revenues on the concert circuit in 2003. Together, they took in $196.4 million from ticket sales. If Celine Dion took in $35.4 million more than Bruce Springsteen, how much did each generate? So together, 196.4. She did 3.5 million more. So I'm going to write this something like this. Bruce plus Celine, that's them together, make 196.4. Celine is 35.4 more than Bruce. So I can express the story in terms of an equation. So putting these two together by substituting the C with this, I get Bruce plus 35.4 plus Bruce equals 196.4. So I'm going to say 1 Bruce plus 1 Bruce, 2 Bruce Springsteen plus 35.4. So that was combining like terms. I'm going to subtract 35.4 from both sides. And I'm going to get twice Bruce Springsteen equals 160. Let's see, 4 minus 4 is 1. And divide by 2. And I get Bruce equals 80.5 million. Did that answer the question? It says how much did each generate, so I also have to say how much Celine did. She did 35.4 plus the 80 because she made more than Bruce Springsteen. So hers is 115.9 million. And that answers the question. Oftentimes when you'll be doing online homework, they might have two different answer blocks, so just read, or they might ask you just for Celine or just for Bruce. So I happen to use an equation to solve this, but that's not the only way that you can go about deducing the situation. But you'll often see me translate a problem. At the 2004 Olympic Games in Athens, Greece, the United States won 103 medals. There were 4 more silver medals than gold. The number of bronze medals was 6 less than the gold medals. How many of each kind of medal did the United States earn? So just from reading the problem, we know we're going to need 3 numbers as our final answer: our gold, our silver, and our bronze. And we expect the silver to be the biggest number, the gold to be in the middle, and the bronze to be the last number because of this description that there were more silver and less bronze. So bronze plus silver plus gold, all of the medals together, has to be 103. Silver was 4 more than the gold. Bronze was 6 less than the gold. So that's how we can describe all of those things. And then we can put them together and say the gold minus 6, that's substituting in for the bronze, plus the gold plus 4, that's substituting in for the silver, that's the bronze, that's the silver, plus the gold equals 103. So we can take all the information from the problem and put it into this one equation. So all together we have 3g, 1 there, 1 there, and 1 there. And then negative 6 and plus 4 is negative 2. So addition property of equality, we'll add 2 to both sides. And we get 3 times the gold equals 105. And we'll divide both sides by 3. And gold equals 35. Now, a couple things to note. We got a whole number, and that's what we're expecting. Nobody gets half of a medal, so that makes sense. So that's one part of making sense. And then remember, we have to answer our question. So we now know the gold, but the silver is gold plus 4, so 39 silver medals. And the bronze is 35 minus 6, which is 29. And you could always go ahead and take your calculator and check that 29 plus 39 plus 35 gives you 103. A standard calendar is printed on paper, so where the length is 4 inches longer than the width. So my picture's actually not a good picture. Let's see. The length is longer than the width. And the perimeter is 56 inches. What are the dimensions of the paper? Perimeter is the length around the edge. So if we go all the way around, how far have we gone? And you're given the formula. Remember, all formulas that you need will appear in the problem. So we have the length and the width. And we know that the length is 4 inches longer than the width. And we know that the perimeter, which it gave us the formula, is 56. So we can replace the L with W plus 4. Because that's replacing this in there. And we get 2W plus 8. We have to remove parentheses first. Combine like terms. Addition property of equality, we subtract 8 from both sides. And we divide by 4. So we get that the width equals 12 inches. And then because the length is 4 more than the width, the length is 16 inches. And again, just pay attention to what you're asked for. This says the dimensions, which are length and width. It would probably be 2 answer boxes on the homework, but maybe when you take the test, it'll just ask you what is the length. So make sure you answer that. A parking garage charges $5 for the first hour, then $3 for each additional hour. How much does it cost for 2 hours? So if you're asking me 2 hours, I'm probably not going to think of a formula. $5 for the first hour, $3 for the second hour. So altogether $8. How much does it cost for 16 hours? And again, I could come up with a formula. So first hour, second hour, third hour, fourth hour, fifth hour, fifth. Lots of threes, right? If this is the first hour, then I actually have 15 additional hours that run at $3 a piece. So $5 for the first hour, then $3 for each additional, and if I'm there for 16 hours, there are 15. This is 5 plus 45, so we get $50. Now we kind of need a formula to work with. I guess we could just sit and repeatedly subtract. We know it's longer than 16 hours if it cost us $68. You could sit there from 50 and say, okay, that's 16 hours. That's 17 hours, 18 hours, 19 hours, 20 hours, 21 hours, 22 hours. So 22 hours. So you could deduce that and never write a formula on your paper. If you want to express this as a formula, it's kind of an interesting formula. It costs $5 plus $3 times h minus 1, because you're only going to have one fewer of the hours that are $3 hours. I've also seen people write this as $3 times the hour plus the $2 extra you pay for that first hour that you're there. And that's another way of thinking about it. And so you could say 68 is 3h plus 2. And divide by 3, and you get 22 hours that way. So a formula is good, a formula is efficient, but especially if you're having a hard time or if there's something about the phrasing that's throwing it off, but you can calculate it yourself, you should feel comfortable doing that. If you have any other questions, let me know. The word problems can really come in almost any type. They could be a formula. They could be one where you want to draw a picture. They could be one where you just want to compute it by hand. You may even want to go back to homework 1, the one about arithmetic, and look at some of the word problems there, because we had some arithmetic word problems back then. But if you're having trouble, you should let me know, because not only can I help you with that homework problem, but I can give you something similar with different phrasing to practice. So you should let me know if you're having trouble.